All right, so what I'm going to talk about today is Le Chatelier and how you're going to see some of these problems and what we're going to be expecting you to be able to do. So we have this equilibrium reaction. Again, it is reversible. And so what I want to focus on is what is the setup for this equilibrium, including where is the heat located. So if the heat is on the left-hand side, this is what we call an endothermic process. If the heat was over here on the product side, it would be considered an exothermic process. The other thing I do when I look at a balanced chemical equation is I try to focus on states of matter. So I see that everything here is a gas. So on the left-hand side of my reactant side, I have 1 mole of gas. And on the right-hand side, I have 2 moles of gas. And the reason I do that is because if I have any change in pressure in my equilibrium, I could then look at that and know which side has more or less moles of gas. So what you're going to be asked to do is which way will the reaction shift? Okay, so what we're going to do is add, change things, add heat, take heat away. All of those things are going to be what we focus on. So this is adding Cl2. So look at Cl2, that is on the product side. And always keep in mind with equilibriums, reactants are always on the left, products are always on the right. Even though it's reversible, you need to keep that the same. So this is the reactant side and this is the product side. Okay, so I am adding a product. So this is a product I'm adding. So I'm increasing the amount of Cl2. Okay, so I'm increasing the concentration. Well, anytime I increase the amount of product, it's going to try to alleviate that stress and shift it back to the left. So what I'm going to say is this shifts left, so I could just draw a left arrow. And what that means is I'm going to make more reactant. So the amount of reactant that I get is then going to increase, and Cl2 eventually is going to decrease. Increased pressure. Okay, so the rule is if I increase pressure, I want to go to the side with less moles of gas. Okay, so what you have to do is look at the balanced chemical equation. Again, you're looking at the stoichiometry and seeing how many moles of gas you have on each side. So I have 1 mole of gas on the reactant side. I have 2 moles of gas for this particular reaction. So if I'm shifting it to the side with less moles, that means I'm going to make more reactant. So it's going to shift left. It's going to shift left. Then I could look at heat. Okay, so I could add heat or remove heat. So remove heat, I could put it into an ice water bath and I could cool down this reaction. Well, anytime I remove heat, I am digging a hole. So I want you to think of that image. So if I'm taking heat away from the reactant side, what it's going to try to do is make that heat up. So that means it's going to go towards the left and try to fill that hole. So think of filling a hole with dirt. So I'm going to try to shift it to the left. So I'm going to go to the left and I'm going to make more reactant. Besides adding something to the equation, I could also remove, either mechanically, like physically taking it out of the reaction, or I could add a chemical that removes it. So I'm going to remove PCl3. That is removing a product, so I'm going to dig a hole. So I'm digging a hole on the right-hand side or the product side. So again, it doesn't like the hole being dug. It wants to fill it back up with dirt. So the only way you can fill it up with dirt is to go towards the right. So I'm going to make more product. So I've given you a couple other examples, but I thought it would be helpful to kind of give you a audio on what this type of reaction looks like.